Hey y'all, it's me, Miss B, and today we are looking at asymptotes and relating them to limits. Now, this is stuff we've actually already kind of looked at. We've looked at rational functions before, but now we're relating them. So we're talking about rational functions, but we're relating them back to the graph. So why certain things can't happen. Okay, and this is a really important point that we want to talk about. Okay, so the first thing is vertical asymptotes. Okay, so I'm going to draw a random vertical asymptote at 2, just because I can. And I'm going to go ahead and look at, let's go ahead and create something that goes that way, and then something that goes that way. So usually we have, with rational functions, we have something that has also a horizontal asymptote as well. So what I want to do is I want to train of thought there. Okay, so what I want to do is I want to look at this. So from at -2, if I look at my limit, or I'm sorry, +2, as the limit approaches +2 from the left and from the right, they're going in different directions, so it does not exist. So from the left and from the right, we're getting different things, so it does not exist. Okay? The limit, as x approaches anything else, like for instance, -1, for -1, it's approaching 1.5 from the right and from the left. So it really just doesn't exist at that limit for the rational function. Okay, then for holes, I'm going to have some kind of graph with a hole in it. We've seen holes before. And it's gonna, let's get kind of fancy with it. So my graph might look something like that, right? And so try and draw something like that. So the limit as x approaches that value, in this case it's 2, from the right and from the left, it's approaching the same value at 1. However, at 2, f of 2, it does not have a value. It doesn't exist. There's no solution for that. Okay, so there's no solution for that. So that's what happens with holes in vertical asymptotes. Now we're going to do a little algebra to kind of back it up here. Okay, so if I have a graph x over x plus 2, so if I were to set the denominator x plus 2 equal to 0, like we've done before, then I subtract 2 from both sides, then x equals -2 is a vertical asymptote. So I have a vertical asymptote at x is equal to -2. Okay, so at that vertical asymptote, let's look at the limits. For whatever reason, I got cut off here. Let's go ahead and move that up. Okay, so the limit as x approaches 2 from the left is going towards, it's going up and up and up, so it's going towards positive infinity. From the right side, it's approaching negative infinity because it's going down and down and down. So because infinity and negative infinity do not equal each other, the limit does not exist at -2. Okay, and that is the simplified version, so there's no simplifying. The limit just doesn't exist there. Okay, and so if we were to create a table, for instance, like we talked about before, so with a table, you would see this right here, okay? So So you would see it approaching infinity and negative infinity. All right, so looking at a whole, again, we've got this here. I'm going to go ahead and factor the numerator. Here's my function. So I've got 3. Oh, this was supposed to have an x in it. Dang it. Okay, so if I factor out a 3x from both of these, then I'm left with x minus 1 over x minus 1. Okay, and what happens is these x minus 1's cancel, and I'm left with just 3x, which is a line, okay? But with a whole, because it canceled out in the numerator and denominator, at x minus 1 is equal to 0. So x equals 1 gives us a whole. Okay, so you can see that that whole is created, and there's the algebra to go with it. So this right here should be, I changed the problem a little bit, and then I didn't go back and change everything. So as x approaches 1, there is a value, because from the left and from the right it equals 3, but there's no solution to that yet again. So there's no solution because for f at 1. Okay. So again, that was really just to reiterate points that we've already learned before. And that's all for today, folks.